Hello learners, welcome to Chemistry Nuggets. I'm Akanksha and in this video I'm going to explain you about electronegativity and its application to the metallic and non-metallic character of the elements. So this video is divided into two parts actually. In the first part I will explain you the non-metallic character and in the second part I will explain you the metallic character. So let's start it. So let me tell you the bookish definition of electronegativity. It says the tendency of an atom to attract the shared pair of electron in a covalent bond is called its electronegativity. But we need not to bother a lot about this. So first of all, I'm going to read the questions what I am going to take to solve in this topic. The first question is, consider the element boron, carbon, nitrogen, then fluorine and silicon. Find the correct order of their non-metallic character. And the second question, what I will going to solve in the second half portion of this video is, considering the element boron, aluminium, magnesium and potassium. Find the correct order of their metallic character. So let's take the question number 1. So here it comes a new term, non-metallic character. What is that? Non-metallic character is directly related to the electronegativity. The non-metals are those elements who are able to attract the electron. Okay, so highly electronegative means highly capable of attracting electrons. It means they are non-metals. So we can say that tendency to attract electron, that is tendency to attract electron is called electronegativity, or we can say it's called electronegativity, and this in return is called non-metals. Non-metals. So we have here boron, carbon, nitrogen, fluorine and silicon. So if we arrange them in the periodic table, so boron having 5 electrons, carbon 6, nitrogen 7, fluorine 9 and silicon having 14 electrons. So in the periodic table, what will be the trend? Boron, carbon, nitrogen, phosphorus and silicon will come here below the carbon. So what is the general trend? From left to right in the same period, they all belong to the same period. Electronegativity increase. Okay, and from up to down in the group, electronegativity decrease. Now, why this happens? Electronegativity increase from left to right because of the increasing nuclear charge. The more the powerful nucleus from left to right, it has more tendency to attract the upcoming electron. That's why the electronegativity increase as we move from left to right. And in a group, electronegativity decrease because of the increasing size. As we move down, the size of the atoms increases. So the nucleus is far away from the outermost shell. So it has very less power to attract electron. That's why bigger the size, smaller the nuclear electronegativity. So According to this tendency, or we can say this trend of electronegativity, we can say we can arrange the given things in the order, correct order of non-metallic means we can say fluorine is highly electronegative. See here, in this way it is increased. It means fluorine is highly negative. Then it comes nitrogen. Below that it comes carbon, and after boron. And it decreases like that. It means silicon in a group. Silicon has the lowest electronegativity. So we can say this is the highly electronegative, and this is the what we can say, we can say in terms of metallic and non-metallic character. So which is highly electronegative is highly non-metallic. It is non-metallic. Fluorine is non-metal and it decreases in this order, and this is silicon is also non-metal, but its electronegativity is lesser in comparison to other. So this is the general trend as the given elements. We have the answer of arrange them in their non-metallic character. Let's take the second question. It is considering the element boron, aluminium, magnesium and potassium. Find the correct order of their metallic characters. So what is metallic character? We will check metallic character. So earlier we read that electronegativity is directly proportional to non-metallic character. So the opposite of non-metallic is metallic. That is the elements who can we can say the elements who can remove the electron easily and does not take the electron are called electropositive, or in other terms metallic, which is opposite to non-metallic. So electronegativity and metallic character is also opposite to each other. If electronegativity is increased along a period, metallic character will decrease along the period. And if electronegativity is decreased down the group, metallic character will increase down the group. So we can write a general formula. Electronegativity is inversely proportional to metallic character. So let's see, this is the formula what we are going to use, and after that we will first of all write the configuration of the elements given so that we can get their positions in the periodic table. So first of all we have boron having 5 electrons, so 1s2, 2s2, 2p1. Then we have aluminium 13, 1s2, 2s2, 2p6, 3s2 and 3p1. Then magnesium 12 electrons, 1s2, 2s2, 2p6, 3s2. And the last is potassium. Potassium having 19 electrons. So we will write the configuration 1s2, 2s2, 2p6, 3s2, 3p6 and 4s1. Correct? 6 plus 2 plus 2, 10. 10 plus 6, 16 to 18 plus 19 electrons. Correct? The configuration as we wrote, then we will get the position in the periodic table. How we can get? From the last coming electron. In the case of boron, it is here. In aluminium, it is here. Only we want this last shell configuration. So we can say boron is from, because it is level 2, so we can say period, and we can write the block. Two things we will get. Boron is from second period and block because the last electron falls in p orbital, it is belong to p block. Same in case of aluminium, we will see the last electron in the third level, the third period and p block. Same we can write for magnesium. We don't have space over here. We can write magnesium is from, see here, third level, yani ki third period and S block, and potassium is from the fourth period and S block. So from writing the configuration, we get the exact position in the periodic table. From this position, we will guess whether the given element is metallic or non-metallic, or what is the order of metallic character. So let's see. According to the, we can write period over here, second period, third period and fourth period like this. And here it is S block and then it will be P block. So in the second period and P block, we get boron. If we draw a small periodic table over here for the given element, we have boron, and in the third period and P block, we got aluminium, then magnesium in the third period and S block, and potassium in the fourth period. Like that we get. Now we have some of the idea, somehow we have get the idea, the positions in the periodic table. Now we know that metallic character will increase in this direction. Okay, we can say metallic character increase and also in this way metallic character increase. So let's see what will be the scene from P to S block. It means S block element will be metallic comparatively P block. Okay, so and in this here to here, and in the S block itself, potassium will be more metallic than magnesium according to this rule, which is just opposite to the electronegativity. Our electronegativity is increasing in this way. Electronegativity increase, and our electronegativity increase in this way. Electronegativity increase. We can say like that. So we will just go to the opposite to the electronegativity. So we can say potassium will be highly metallic. After that, magnesium, which is lesser metallic than potassium. After that, we have aluminium, and the least metallic will be boron in the given element group. So potassium will be, we can write highly metallic, and boron is least metallic. This is the explanation.
So hope you guys understand the concept, and if you have any doubt, any queries, please feel free to write in the comment box. Thank you.